Good morning to all. Today we are going to learn another device known as potentiometer. Potentiometer is a device that used to measure the potential difference across two points or to compare the EMF of two cells or to find out the internal resistance of a cell. Normally, to find out the potential difference across two points, we use a voltmeter. But when a voltmeter is connected to a circuit, the voltmeter itself will draw a current from the circuit. So, therefore, it does not provide the accurate measurement for the potential difference across the two points. But potentiometer is a device that can accurately measure the difference between the potential difference across two points. So it is considered as an ideal instrument to measure the potential difference across two points or to compare the EMFs of two cells. Why it is considered as an ideal instrument to get accurate measurement for the potential difference or the EMF of two cells when they are compared? Because potentiometer works with the principle of the zero deflection. That means when a potentiometer is connected across two points, then it gives a balancing point where the galvanometer shows the zero current flows through the circuit. It means there is no flow of electric current when the potentiometer becomes balanced, and that point is known as null point or 0 point. And so when it reaches, the galvanometer reaches the 0 point, means no current is flowing through the circuit, no potential difference between these 2 points. That means the 2 points, suppose we are measuring the potential difference across this point A and B, and both will reach the same potential, so no current will flow through that at that time. So therefore, it gives an accurate value for the potential difference across two points or the EMFs of two cells when they are compared. What are the main components of a potentiometer? So we know that from the figure we can understand that a battery, a cell is connected to the potentiometer, and the cell is here known as a driver cell. And which has an EMF E, and again it is connected to a key, and key then connected to a galvanometer. Galvanometer used to or to measure the current flowing through the circuit, and then galvanometer is then connected to a slider key, or which is called as jockey, and normally a 10-meter length wire is being used in a potentiometer. And this wire is normally made of alloy like constant or magnet. Why? Because alloy has a less temperature resistivity or alpha. And how does the temperature resistivity alpha's value affect the resistance of the conductor? So that this alloy wire has less resistance due to the temperature resistivity or alpha. And if the temperature resistivity alpha is less, then it does not affect the change in temperature, change in atmospheric temperature, or even if it changes, it becomes negligible. So therefore alloys are being used for the wire which is connected to the potentiometer. And again a rheostat is connected to the battery. And rheostat is a variable resistor. We can vary or we can change the resistance. And this circuit is known as a primary circuit. With all these components including the driver cell, key, galvanometer, rheostat, and this wire, alloy wire, which has a less small resistance, all together called a primary cell. In this session we are also going to learn how a potentiometer can be used or two applications of potentiometer, that a potentiometer can be used to compare the EMFs of two batteries or two cells. And also a potentiometer is used to calculate the internal resistance of a cell. And these two applications we will see later. And first let us see how this potentiometer works and what is its principle of working. The potentiometer is working with the principle that potential drops across any point of this wire is directly proportional to the length of that wire when a constant current is flowing through the circuit. That means here the length of the wire is directly proportional to the potential drop across these points. And assume that taking a wire of whose cross-sectional area is A and whose resistivity is rho. Area of cross-section is A and its resistivity is rho. Then we can write the resistance. Resistance R of rho into L divided by K. Here rho is the resistivity of the wire and L is the length of the wire and A is the area of cross section of the wire. So as per Ohm's law, V is equal to I into R. And if we substitute the value of R in this equation, what we will get? I into R is equal to rho into L divided by K. Rho is the resistivity of the wire, L is the length of the wire, A is the area of cross section of the wire. A current I is flowing through the circuit, and this term all together can be written as K into L. So now we can write as V is equal to K into L, or we can write here K is a constant and K is equal to, what is the value of K? K is equal to I into rho divided by A. K is equal to I into rho divided by K. So from this equation, so we know that here the K is a proportionality constant, right? So therefore we can write, we can conclude that V is directly proportional to the length of the wire. Here V is the potential drop across the wire and L is the length of the wire. And that is what we said the principle of the potentiometer. The voltage drop across any portion of this wire is directly proportional to the length of the wire at any portion. From this equation, the value of K can be written, right? So what will be the value? K is equal to V divided by L. And the value, the term K is known as the potential gradient of the potentiometer. Potential gradient is the fall of potential per unit length of the wire. Okay. K is equal to V divided by L. So the potential difference, the potential falls per unit length of the wire is known as the potential gradient of the potentiometer. And the another term, the sensitivity of the potentiometer. Sensitivity of a potentiometer depends upon the potential gradient of the potentiometer. If the potential gradient is less than the balancing length of the potentiometer, wire is increases and the length can be measured with more accurate. So if the potential gradient is less than that of the balancing length of the wire of the potentiometer, then it is increases. So potential gradient is less means the length of the wire is increases. And this is why the reason a long wire is used in the potentiometer. If the length is increasing, then the potential gradient of the wire or the sensitivity of the potentiometer increases. So more accurate value for the resistance or the value measured or the parameter measured in the potentiometer will be more accurate if the length is increased. Now we are going to see one of the applications of the potentiometer, that is Whenever the EMFs of two cells are being compared, a potentiometer can be used to get the accurate measurement for the comparison of the two EMFs of two cells. So here in this diagram you can see that a driver cell is connected to the potentiometer and a ammeter is also connected to the cell to find the current flow through the circuit, and a variable resistance rheostat is connected through the key A1, and again from the point A, two cells whose EMFs are E1 and E2 are connected through a key whose EMFs are to be compared, and again a galvanometer is connected to the key, and galvanometer then connected to the slider key, it's called as jockey, to get the balancing length of the wire. So here one thing we need to remember that the EMF of the driver cell E has to be higher than the EMFs of these two cells whose EMFs to be compared. And if the EMF of the driver cell is less than that of the EMF of the other two cells whose EMFs to be compared, then we do not get a current accurate value for the EMFs of these cells, because if the EMF is less than that of the other two cells, then the potential difference or the potential drop across these 2 points also will be very less. So we do not get the accurate value for the EMFs of the cells. In order to find out the EMF of these, to compare this EMF of these two cells, first introduce the cell E1 to the circuit through the key K2, and when K2 is open, introduce this EMF E1 so that the jockey can be touch at the various positions of this wire, where we get a length L from the point A to L, where the galvanometer shows the 0 point. That means when both point A and B attain an equal potential drop or equal potential, then it shows a 0 reading on the galvanometer. That means that point is known as null point. And assume that the length is L1, where at this point the galvanometer shows the null point. So write this, measure the length L1, length of the wire from the point A. Then we can write the EMF of the first cell E1. E1 is equal to K into L1. This equation we already have. K into L1. And now we have the length L1. Now we introduce the cell E2 to the circuit through the key. Then also follow the same procedure and slide the jockey over this wire and get a point where the galvanometer shows the 0 measurement on the galvanometer, and take suppose this is the length L2 is the length by which the galvanometer shows the null point, and then similarly we can write E2, that is the EMF of the second cell, is equal to K into L2. And now if we compare from these two equations, we can write E1 is equal to E1 divided by E2 is equal to L1 divided by L2. That means the ratio of the EMF of the first cell and second cell is equal to the length on the wire when the first cell is connected, and the length of the wire on the wire when the second cell is connected. So the EMFs of these two cells are ratio between the two cells are equal to the lengths of the wire Now the second application of a potentiometer is to determine the internal resistance of a cell. So in that case, from the diagram you can see that only one difference is there. The cell whose internal resistance to be calculated is connected to the key 2, and instead of a second cell, a resistance of known value is connected here, and the rest all the circuits are same. So this primary circuit is as it is, and the secondary circuit only instead of the second battery or cell, a known resistance box, a resistance box whose values are known connected. Then how we can calculate the internal resistance of a cell by using this circuit? So here first of all introduce, when the key is open, the key is open and the battery, calculate the EMF of the cell connected, and key is open, the no current is flowing through the circuit, and the EMF of the first value, and find out the null point in the galvanometer and take the length. A length L1 is to be taken when the K2 is open. So find the null point in the galvanometer and find the EMF. So the EMF E can be written as E is equal to K into L1. And now the key is closed now. When the key is closed, then an electric current will flow through the circuit. The electric current will flow through the resistance box R, and then there will be a potential difference, and that potential difference is known as terminal potential difference. So then if V is the terminal potential difference across this resistor, then the null point is obtained at a length L2. Null point will be obtained at a length L2 when the resistance box is connected to the circuit, and the terminal potential difference can be written as V is equal to K into L2. Now from the same way, and we can take the ratio of the EMF of the battery or the cell and the terminal potential difference. So we will get E divided by V is equal to L1 divided by L2. The ratio between the EMF of the cell and the terminal potential difference across the resistance box is equal to the ratio of the lengths at this frequency. So here, and also we know that the internal resistance of a cell R is equal to, what is the value of the internal resistance R? E by V minus 1 into R. So here the E by V, that is the ratio between the EMF of the battery and the terminal potential difference across the resistance box. And instead of E by V we can write L1 divided by L2 minus 1 into R. So the internal resistance of the battery can be calculated by this equation. R is equal to L1 divided by L2 minus 1 into R. And if we know the values of L1, L2 and R, then easily we can calculate the internal resistance of the cell. I hope you understand. Thank you.